for 4-1C, we have knowns, which is your T initial 900 degrees C, your infinite temperature is 35, you have some givens for the properties, and we want to find the time for annealing, the amount of each transfer from a single ball. So we want to assume that the balls are spherical, there's constant thermal properties, and the lumped analysis applies. So that's because the BI is over 0.1, which we proved below. And then the collected length is just volume over area, surface area, and that simplifies to d over 6, you get 0.0013 meters. Next, B is equal to HAS over rho CPV. Plug that in, you get 0.1584 seconds to -1. Then we can use this equation, which is given from lumped analysis, and that's e to the negative bt. Plug in your temperatures, and we get time is equal to 2.7 minutes, and that's solving for T. Since mass is equal to rho V, we can solve for that. Your volume is pi d cubed over 6 and 0.0026 kilograms, and Q is equal to mcp, and your difference in temperatures, you plug that in, you get 0.781 kilojoules. And then Q for one ball is the number of balls times what your Q for solved above, and you get 543 watts. Next, for 4-100, it's kind of the same process except for using the error function. And we have known there's a 10-hour period, and we want to find the temperatures at each point under the Earth's surface. So T infinite minus T I, and then ERFC x over 2 square root of alpha T. It's just this equation. This goes to 0 because the error function at n goes to 0 when n is greater than 4. So this is squared 1,138, and then T0 at 10 hours is -8 degrees C. Plug in the values that were given above, and then here it's -8 for T infinity, 15 degrees for Ti initial. You get -6.3, same idea, 4.6 and 0.2. Next, we have our knowns. For 4-115, we want to find our BI number of each wall, and it's different because there are different lengths that were corrected. We have L1 and L2, 0.02, 0.06. We have our given lambdas from the table 4-4, and then you want to find our theta with the given equation. You get T is equal to 19.5 hours. For 14-89, there's 40% reduction of the carbon amount, and we want to find the concentration at 1 hour and 10 hours. So then we use our concentration equation and the error function. So we get ERFC to this is equal to 0.6 based on table 4-4, and then over 2, x over 2 square root of DABT is 0.371. And then to solve for our time, you just want to solve for T, which is on the bottom at the different times, and you get 0.0141 centimeters for 1 hour and 0.0445 centimeters for 10 hours.